Okay, so welcome back. I'm going to be going through what's called integration by substitution. This is basically undoing chain rule with integration. And it is very powerful, but also a little bit confusing, so I'll be going through a bunch of different examples. So the goal is to undo chain rule with integration. We'll be using it with constant multiples, definite integration, and trigonometric functions. So before I get started, these are all of our integration rules so far. Okay, I'm not full screen, so let me come back and try that again. Oh, there we go. Okay, so these are all of our integration rules so far. This first one is called the first fundamental theorem of calculus. Which is our general rule for integration. Which just says if I integrate some sort of a derivative, an already derived function in terms of x from a to b, then I'll step up, so I'll get back to an original function that was not derived yet. But then I'll have to plug in my upper bound and subtract my lower bound. Upper bound, lower bound. Which is true regardless of what we're integrating. If I wanted to undo power rule, then I would add 1 to the power and divide by the new power and divide by dx. If you don't have bounds, then you'll always end up with a plus c, since we don't know if there was a constant there. If you do have bounds, you'd plug in your upper bound and subtract your lower bound. Okay, we have all of our trig functions, all 6 of them, that we could undo. Any questions on any of the rules from last time? Okay. And jumping into new stuff. So when we derived with chain rule, what we did was we took any inside function that we had and treated it as a separate function. So right now I've got some function, all of this inside part, raised to the 20th power. So I can multiply by the power, decrease the power by 1, and then multiply by the derivative of the inside function with chain rule. So this would become this whole function times 20 raised to the 19th power times the derivative of the inside part is 3x squared plus 4. And then I've actually got a second chain rule here, times the derivative of the inside part is dx.
So you do derive 3x squared plus 4?
I've derived this part.
Will
So
we? So it's like 20 times x cubed plus 4x minus 6 to the 19th power times 3x squared plus 4 and then 6x?
no, I'm not deriving this entire function. I'm just deriving an inside part. So for this case, my inside part is x. So I could say if x is really the sine of x, then I could substitute x for sine of x in here, but my derivative of x would become cosine x. We use chain rule whenever we're deriving a function within a function. So in this case, this whole function is inside what I'm raising to the 20th power, so that's why I derived it to get this part. But the only function I have inside 3x squared plus 4 is x itself. So I'll have to multiply by the derivative of x. Okay, so if I wanted to undo this, which means I want to start from here and go to here, We'll do all of those steps backwards. So the first thing we need to do is we need to figure out what our inside function was. So in this case, I'm going to define a new variable for it. So I can say u is equal to my inside part of this function. So the part that I'm raising to a large power, which is x cubed plus 4x minus 6. In that case, when I derive this, I'll figure out what I needed to multiply by with chain rule originally. So if I derive x cubed plus 4x minus 6, I get 3x squared plus 4dx. Okay, so now I'm going to substitute. Anytime that I see an x cubed plus 4x minus 6, I'm going to replace it with u. And anytime I see everything that I had with chain rule, I'm going to replace it with the derivative of u. Okay, so that gives me, after I substitute, 20u to the 19th power du. And then I can integrate normally using my my power rule for integration. So I'm going to add 1 to the power, divide by the new power, divide by du. So 19 plus 1 is 20. I'm going to divide by 20 because that's my new power. So my 20 and 20 will cancel. Divide by du will give me no du's here. And then add c. Okay, so that gives me u to the 20th power plus c. Then I can go back and resubstitute for u. So anytime I see a u, I'm going to replace it with x cubed plus 4x minus 6. And I've got my answer. My original function was x cubed plus 4x minus 6 to the 20th power plus some constant, which is true. Our constant just happened to be 0. In order for this to work, when you do your substitution, all of your variables need to be replaced. So we cannot have any mixed variables where we have some u's and some x's. We'll also need to substitute for the original inside function for U substitution to work. So if we guess wrong, we may need to do it again. Okay, any questions on this slide?
No.
Okay, so I'm going to try another example. So it's possible that we'll have constant multiples as well. So I'm starting here on the left. So I'm given that we had a already derived function we want to work backwards from of 4x squared plus 5 raised to the 7th power x dx. Okay, so my inside part of this function is what I'm raising to that large power is 4x squared plus 5. When I derive 4x squared plus 5, I get 8x dx. 8x dx. Problem is, I don't have an 8 here. So what I'm going to do is I'm going to multiply by 8 and divide by 8. Multiply by 8 and divide by 8 at the same time.
Your mic is...
My mic is muted. Okay, can you hear me now? Can you hear me now?
Yes.
Yes.
Okay. Not really sure what I did there, but okay. So I'm going to start over. What's the last thing you guys heard? Okay, nothing for this slide. Did we get everything?
This slide.
Okay, just on this slide. Okay, cool. So use substitution with constant multiples. I'm over here on the left now. I'm going to start with this function and work backwards. So my inside function is this 4x squared plus 5. So I'm going to replace that with u. If I derive 4x squared plus 5, I get 8x dx. My problem is I don't have 8x dx. I only have 1x dx. So what I'm going to do is I'm going to multiply by 8. That'll give me the 8x dx that I need. But also divide by 8. That way I don't change the original problem. 8 times 1/8 is 1. And if you multiply by 1, you haven't changed anything. Okay, so that means when I substitute, I can pull out this 1/8 out of the integral because it's a constant multiple. That gives me an 8x dx, which we can substitute for to get our du. Okay, our inside function, 4x squared plus 5, we can substitute for to become u. And now I can integrate normally. So if I integrate u to the 7th power, I get u to the 8th power divided by 8 times the 1/8 that I already had on the outside, gives me u to the 8th over 64. And then I can substitute u is 4x squared plus 5 in for u to get 4x squared plus 5 to the 8th power over 64 plus c for my final answer. Any questions on what we did here? Okay. If I've got trig functions, the same thing happens only when we're working backwards of the trig function rules. So here I've got sine squared of 4x. It's the same thing as the sine of 4x squared. So my inside function right now is really this part, the sine of 4x. So I'm going to set that equal to u, and when I derive, I get 4 sine 4x, but I don't have a 4 cosine 4x. I don't have a 4 cosine 4x, I only have a 1 cosine 4x. So I'm going to do the same thing as last time. I'm going to multiply by 4 and divide by 4 so that I have the 4 cosine 4x to substitute for my u prime. Okay, so here's the 4 cosine 4x dx is u prime, and the sine of 4x is u. So I could rewrite this as u squared times u prime times 1/4. Okay, if I integrate this will be u to the 3rd power over 3 times 1/4 plus c is u to the 3rd power over 12. U is the sine of 4x, so this is the sine cubed of 4x over 12 plus c for my final answer. Any questions on anything from this slide?
Why did you get 4 in front of cosine when you started solving?
So when I started solving, my original inside part for this first step, because this is the sine of 4x squared, my inside function is the sine of 4x, right? So if I derive sine 4x, I'll get the cosine of 4x times 4, right? With chain rule.
Oh.
So that's where the 4 came from, but I did not have a 4 in my original problem, so I can't substitute for 4 cosine x directly until I've got that 4 in there. So what I'm going to do is I'm going to multiply by 4. That'll give me the 4 that I need. But so that I don't change the original problem, I'm also going to divide by 4. And that'll get me to this step. So here I've rewritten everything we just did. Multiply by 4 and divide by 4. This 4 cosine 4x is all u prime. The sine of 4x is my u. So that gives me 1/4 u squared u prime. Okay, any other questions on this one?
No.
Okay. So if I've got definite integration, so this time we've got bounds is all that means. Our bounds are defined. Our steps are going to be the same until we go to substitute. And then we can actually cheat a little bit. So with definite integration, I can leave my answer in terms of u and just change my bounds so that they're in terms of u instead of in terms of x, and get a number answer without having to change back into x. I'll show you what I mean. So I'm going to do this the same way that we did last time for our substitution. My inside function is 4x cubed plus 2. So that's going to be my u. If I derive 4x cubed plus 2, I get 12x squared dx. That's my u prime, which I don't have. Right now I've got a 6x squared dx. So to get 12, I would have to multiply by 2. But I don't want to change the original problem, so I'm also going to divide by 2. Okay, so this 2 will be a part of our du. 2 times 6x squared gives us 12x squared dx. Okay, I'm also going to change my bounds. My upper bound was 2. So if u is equal to 4x squared, 4x cubed plus 2, then I can plug in 2 for x and figure out how many u's are in 2x. So if I plug in 2, I get 4 times 2 cubed. That's 4 times 8 is 32, plus 2 is 34. So my upper bound will now be 34 after I substitute. This 2 will become 34. For my lower bound, which was 1, when I plug in 1 here, I get 4 times 1 cubed plus 2. Gives me 4 plus 2 is 6. So when you go to substitute for your lower bound, you'll get 6 instead of just 1. Okay, then we can make our substitutions for our u and u prime. My u is my inside part, 4x cubed plus 2, so that'll become u to the 5th power instead. And then my du is 12x squared. That's the 2 times the 6x squared will become du. Okay, any questions on our substitution? Okay, so then from here we integrate normally. So if I integrate u to the 5th power, I get u to the 6 over 6 times the 1/2 is u to the 6 over 12 from 6 to 34. I'm going to plug in 34 and subtract what happens when I plug in 6 to get my answer. If I do this, I've got a massively large number. 34 raised to the 6th power divided by 12 minus 6 raised to the 6th power divided by 12 gives me 128,729,813.3, which would be my final answer for our integral. Okay, now if you wanted, you could have instead, at this step, replaced your u with x. So u is 4x cubed plus 2. So this would be 4x cubed plus 2 raised to the 6th power over 12 from your x bounds of 1 to 2. And if I do that, I'll plug in my upper bound to get 4 times 2 cubed plus 2. That's 4 times 8 plus 2, or 34, to the 6th power over 12. Minus, when I plug in 1, that's 4 times 1 plus 2 is 6 to the 6th power over 12. And you would get the exact same answer when you plug into your calculator. 128,729,813.3. Any questions on what we did? Okay, so I've got several practice problems for homework that I've posted to the WeChat and the Skype chat. I will also post on course sites. Before I let you go, this week is the last week of quarter 3, which means our progress reports will be going out next week after they print them out. But our grades are going to be complete at the end of this week. I can still change grades, so I can still add grades for this week and next week. But after Thursday of next week, I cannot change grades anymore. So if you have any incompletes, please go on Gradebook and double check. I know sometimes I've had submissions that if I'm not on my computer, have gone to my phone, and I may have missed when I was grading. So if that's the case, just let me know, and I'll go back and check through my phone, resend to myself, and be able to get you that way. But please double check and make sure that you don't have any incompletes on Gradebook. So we've got this week and next week to fix it. By Thursday next week, I can't change anything.
How do we get our report card?
I'm not entirely sure. My guess is they'll do it through email. So your parents will be sent directly. So please check with all of your classes and make sure that you've talked to your teachers and finished all your incompletes and stuff, not just mine.
So quarter 3 is ending
On Friday.
this week?
Quarter 3 officially ends Friday. However, the teachers still have another week to finish grading all of the stuff from this week. So you won't get the report cards back until Friday of next week.
Also, like, the last day that the teachers can put in the grades is Friday next week.
It's actually, I believe, Thursday next week, so I need to print it.
Did you finish the AP classroom?
Yes. We're still in class.
For physics.
Oh, okay.
Alright, good luck on your physics, guys. If you don't have questions, I'll go ahead and let you go.
Okay.
Goodbye.